Okay. Hi, everyone. I'm Bruno. I'm iOS engineer at Archer/OkCupid. I've been doing iOS for the past 11 years. And there's been a lot of changes in the iOS environments. And today I would like to talk about this thing that I've been working for a while. And it was in the beginning an architecture for routing. And in the past, it was just like managing UIKit because we didn't have SwiftUI. But now I'm going to talk about how we can architect something to route through an iOS application using either SwiftUI, UIKit. It doesn't matter. It is like an abstraction, and you can develop your views the way you like. So the problem, routing through different views on iOS requires a lot of manual work. And a lot of times there's a lack of pattern and code duplication in order to make it happen. So if you work in large code bases, I think you've already noticed, like a lot of times you have to initialize a view controller, unwrap like a navigation controller, and then do manually like a push, present. So all these things is everywhere, and you don't really know like what is the routing that your application support, like where you can go, like it's all over. So it's kind of like difficult to know like, okay, like I don't know how it works. So before I move forward, I just want to go through the iOS way of navigation. This has nothing to do with any framework, UIKit or SwiftUI or whatever. So basically we have a push style, which is a UIKit name, but in SwiftUI is named navigation link. And for that, we can do like in UIKit animated or not animated. And I think here I have an example. If you use like a push presentation, not animated, you're not gonna have an animation, but it's the same concept. And also we have the present way for UIKit, which you also can do animated or not animated. And on top of that, I don't know if you remember, but you have like that modal overlay where you can set like over full screen context, over context, have like some other options to make the thing full screen or just the regular sheet, and also present animation or not animation. Go to the next slide. So yeah, the UIKit way, you get a view controller, then you can set this modal presentation style where you can put like full screen over current context or whatever. And the way to push, you need a navigation controller, you push your view controller, and if you want to present your view controller in a sheet style, you call this present function. And the same applies for SwiftUI. It is just a different naming. If you want to push in SwiftUI, you're going to call this navigation link. And differently than UIKit, if you want to present something modally, you use the sheet or the full screen cover. And the solution, so implement an architecture that supports routing between views independently of the framework, UIKit or SwiftUI, or who knows if Apple is going to introduce a new one in the future. So it would be pretty cool if we could just like know the routings that we have in our application and simply say like, okay, route from here to here. And I don't know, like if a product manager asks like, do we support like migrating the user from this point A to this point B? It would be like easier to know how these things are set up. So let's go to the project, and I'm gonna do a quick walkthrough about this. So here in this example, I have the Swift Packet Manager, which is the routing architecture. But this, if you're gonna use, if you are interested in using this in the future, this could be an XC framework, or if you're not supporting like frameworks or modules in your application, it could live in the main target of our project. It doesn't really matter. So let's start by this documentation. So this module manages routing between views in the application independently if the views are developed in UIKit or SwiftUI. It allows the application to implement a routing pattern using dependency injection for all views. So let's start by sections here. So there's a file here called transitionstyle.swift. So this defines the style of the routing that will be performed. There are two different ways to show a view onto screen, as I mentioned before, a push view controller in UIKit or a navigation link in SwiftUI, or a present style in UIKit or a sheet/full screen cover in SwiftUI. So let's just go here. This is just like a simple enum where I have like 4 cases. This is like for for UIKit routing, where we can get the navigation controller for pushing and a view controller for presenting and a flag to say if you want this transition to be animated or non-animated. And SwiftUI, we don't have this option. So it's basically like the target view that you want to go to. And if you want a sheet view, this is going to have this is full screen Boolean, which you're going to see in a little bit, which is going to just choose the full screen context or the sheet context. Router.swift. So this is a protocol, the router protocol, and it should be used across SwiftSyntax Manager, XC frameworks, or in the main projects if you don't have your application modularized. And it is responsible for routing from view A to view B, either using UIKit or SwiftUI. And this is a good thing to point out. Even if your view is developed in UIKit, it is possible to route using a SwiftUI style and vice versa. Also, this router protocol is going to be used for defining the main view for your feature. Let's say that you have like a search feature, I don't know, like a settings feature. Usually you're going to have a main view to be the starting point of that feature. Let's imagine like a tab bar application or something. So if you open this router, so this is just a protocol where I have the main view controller, which is a UI view controller, and a main view, which is the any view here. And I just make them optional here because you're going to have one or the other in your module, and it's up to you to choose whatever you want. And then I have this route function where it's going to be used for routing using the UIKit framework. And as you can see here, we just import UIKit and SwiftUI into this file. So then here you can like say the view controller that you want to route to. You can also specify the modal presentation style if you want a custom one. And then here you're just gonna have this thing defined in one single place. You will never see this again like across your application. Another thing that I have here is just a helper. Let's say like your application is 100% SwiftUI, but product wants you to implement a third-party framework, and this third-party framework has only UIKit view. So here you could like just wrap your view, actually the opposite. Like you can wrap your SwiftUI view into a view controller, and then you could use this without any problems. And differently than this one, that is a function in the router for UIKit, here we have an extension for a SwiftUI view where you can just create your view and then you can say, okay, route to the destination view that I want. And then here you can also set your style if it's going to be a sheet or, yeah, then this is the thing, like that's the sheet from the enum that I mentioned before. And then this flag, it is just going to get the function that you're going to choose here. So if you're going to be, if you say it is full screen, the full screen cover is going to be used. It's just like a high order function here. And the implementation for the transition is here. And the same thing for the navigation link. So if you want to do a regular push in a SwiftUI style, this is going to do the job for you. And also I have this UI application extension in case your application is developed in UIKit mainly. So you can get access to your current like navigation controller from whatever you are in the application. I'm going to show more examples. Then we have routing interfaces.swift. So that's where all routing contracts are defined, including mocks if you need to. So if you go here, so in this example that I'm going to show a little bit further, we have two dummy modules, like a settings module here and a search module here. So here is where I'm defining like my settings module can route to this email view. Let's say that this belongs to this module. And the search router, let's say that it has a filters module. And in this case, I added like the two styles. One that is going to support UIKit routing and one that is going to support SwiftUI routing. And here also I create like mocks And these mocks are going to be more useful for Swift previews. I'm going to show this a little bit later as well. So you can still like tap things and go to other places. Let me go back to the README file. And then the last thing, the app routes.swift. So this is responsible for initializing the Windows root view controller if you're using UIKit. If you have like an application that is mostly like SwiftUI, you're not going to need this. Also, you can declare the supported routes for your entire application. And also, it's possible to handle deep link. So if you go to the app routes, so all these routes that I mentioned before that is registered here, that's where we're going to define them. And here we have also an extension for deep link, and I go into details for this later. And here is like a concrete type where if you're using UIKit again, you can set your window view controller. So how does this work? Let's go to the main application. So here is that's where everything is initialized for the application. All your modules, everything that you would want in your application, you would be setting up here, and that could be used as dependency injection all over the project. So this conforms to the app routes protocol. Let's just go back if you don't remember. Those are my two routes that are supported in this application. And then here I initialize my router from the application router, which is the one that sets the main view controller in case you have a UIKit application. So what it does, it just like initializes your route, and then you say the main window for the initialization. Then you set also the root view controller. This you don't have to worry about. It's just for the sake of the example. And then the router makes the root view controller. And the cool thing here is, as I mentioned before, things are everywhere, usually like in large code bases, especially if the code base is not a new code base. And this gives us the opportunity like to separate concerns about routing. So let's say you have like, I don't know, 20 modules in your application, but you don't want all your modules to have access to all the routing. So here you can like do dependency injection with the router. So in this example, search router doesn't know about any other router, but settings router would have access to the search router. So it would be possible to, inside of the settings module, route into settings views, but also route to search views. So how is this implemented? Let's take an example for the settings module. So here we have the router. This conforms to the settings router. And as I said before, your application, your feature is going to have a main view that is going to represent that feature. So in this example, like you can do like either if your application is SwiftUI, you can use this one for getting your main view. But if you have a UIKit developed app, you can have a UI view controller. So what this does is, let's build the app for the first time here. So this is my main view controller for the settings. So here I have the settings and the search, which were initialized in here. This is just like the tab bar that I initialized with those two main view controllers. And in this case, I'm just getting this view controller. And if you take a look, I also created these view controller builders. It's a way of organizing like all the views supported by the modules. So if you take a look here, the main view controller is just a regular UI view controller where I have this title and the button. And so that's the thing here now. Since I implemented the routing for settings, so let's take a look at the settings router. We have like route to email. So that's the only route supported right now for the settings module. So let's say now when we tap this button, so let's say when we tap the button, we're going to take the user to the route view. So that's very useful for like if you have a view model or even in the view controller, to tap here. Now you go to your email view, and you can also like use your dependency injection. You can inject whatever is needed. And in this case, I'm pushing, as you see. And I could do anything I want, actually. Like I can say, no, I don't want this to be animated. So it's not animated. Or I could say, I don't want this to be pushed anymore. I want to present this animated. Yes. So it's very handy to like change the presentation style. And also another cool thing is that like if you wanna, I don't know, for deep link or something, if you wanna do a pattern of routings, you could just like call one after the other if you wanna follow like a path, which is pretty cool also. And you don't have to keep adding like all those like dot present, dot push everywhere. So let's go back to the settings. And so this is one example using a main view controller. And this is just like a dummy example also. Like here I have the main view, which is a SwiftUI view. I'm gonna go into more details in a little bit. But this I just added for the sake of the example. So let's say that your application is UIKit developed mostly, and you're using this third-party framework where you have this SwiftUI, or you just started supporting SwiftUI views in your application. You can just use this helper that was in this route extension protocol and wrap your SwiftUI view here and return it. So if we use this one, let's build. Now you see like the main view that represents my application is different, and I didn't have to change anything in this architecture. It's just like the view that represents it. And the same thing for search. Search conforms to the search router that we defined. And then here we have the routing implementations also. So let's take a look a little bit into this view, which is the settings view, SwiftUI view. So that's the cool thing here. You have like multiple ways now to route to different places. So this first button, filters view. So I'm gonna go to the filters view. In external module, if you take a look, this is coming from the search router that lives in another module that has nothing to do to settings, but settings can route to it because we are giving permission to it. And one way is like calling the router dot route to filters, which is the implementation we did. And same thing here, we can use present or push, and we can set specific things here if we need, no animation or animation. Another way is doing the same thing, but with SwiftUI now. So this is the presentation style. And of course, for SwiftUI, you need a binding property. So here you can just like toggle your binding property in the button, and it's gonna be presented. Or that's the cool thing also, like you don't have to keep wrapping now your views into navigation links every single time that you wanna take the user somewhere else. We just call, okay, like this view, route to as a navigation link to this view. And let's see, let's do another test. If I wanna say route with sheet. And then here I could do the same thing, dot email view. Let's say now it's gonna use live test. Then I can inject the search router because I'm giving permission to this to pass my is presented binding property to. And then here I can say like false for no full screen. Oh yeah, I'm gonna have to wrap this in the button. And then your is presented. Yeah. So we have like a lot of different options to say how we're gonna go to another place in the application. Another cool thing is you can implement your view here using previews. And if you take a look, let's refresh this. The downside is that like if you're developing your view in SwiftUI, of course, the UIKit version is not gonna work, but everything else that is SwiftUI you can still like use in your Swift preview, which is pretty nice also. You don't have to keep building your application, especially if it takes a long time to compile. Okay, so this is some styles of doing this. And one more thing, let's show the deep link thingy now. So if I go back to application here, to the main application router module, here I have another protocol, which is the deep link handler. And there is this function called handle deep link, and this helper function to find the values that are coming from the URL. And here I create like a dummy example also, like that's where I'm implementing the settings deep link concrete type. And this is, as you see, like this doesn't live in the settings or in the feature modules. It is just part of the routing itself. And here I'm just creating an example of, I'm gonna get an URL and route to the email view. And the way it is implemented is here, like where I'm initializing the window, I set the view controller, and here's the regular deep link handling function. And the only thing that we call here is handle deep link. So if you go here, I created this dummy thing. And you can see like this goes like to the deep link, which is pretty cool. Right now, I'm just like supporting in this architecture routing via deep link through UIKit, but I'm working on adding the open URL for SwiftUI. But I still didn't get like a clean way of doing this, so it is like a work in progress. But that's mainly, that's it, the talk. Yeah. Yeah. Also, I'm gonna, I think I'm gonna give this project to Jordan, and if you are curious, he can share with people. Yeah.
That sounds great. We'll put a link to it in the iOS Meetup comment section. So we have time for maybe like 2 to 3 questions. Are there any questions in the audience or on the chat? Oh, we got a question.
Hey, oh wow, it's loud. What was your inspiration? Like, did you do any reading and to see similar kind of architectural and navigation styles that inspired this, or was this completely from your own head?
So this thing started back in 2017 when I worked for a client. And back in the day, it was only UIKit, the whole application. There was no XC framework in the code base, no SPM. But the problem was, I've been doing iOS for 11 years. And by that time, all the code bases that I faced in my career, they had this mess of like unwrapping navigation controllers. And that if like the developer took care of doing the clean job of having that thing like properly implemented. So I was like, okay, like, and in this project, I started from scratch, and I was like, I don't want to start this project and after a year or so, find myself in the same situation. So I developed this architecture, which is not how it is, but it's pretty similar to how it is right now, but only supporting UIKit. So if you go here, basically in the beginning, the only thing that existed was this and this with those two cases. And one thing that was like, I'm really like clean architecture, design patterns, and clean code. And when Apple released SwiftUI, a lot of things changed. Like if you create an application right now that you're going to start your application as a SwiftUI application, you don't have already your app delegate. And for me, it's something that I don't like, because UIKit and SwiftUI, it is just a framework for you to develop views. But on top of that, Apple changed the environment of how things work as well. And I think one problem that I see a lot is that a lot of people, they don't think about how your architecture works. It is just like, okay, it's a nice framework, it's easier, let's use. So it's very easy for you to shoot yourself in the foot. And like, especially now, like Apple makes our lives so much easier, but that doesn't mean that you shouldn't think about the macro of your application and how we're going to implement those frameworks. These should be only like details around your architecture, you know? So, and That being said, I started this in UIKit, and once SwiftUI came out, I was like, okay, let me extend this architecture. And it was pretty easy to maintain that because I really had the thinking of, okay, this is an architecture and it doesn't matter which framework is going to be used. And let's say Apple releases something else in the future, or let's say SwiftUI has a huge change. This is not going to affect my application. I'm not going to have to go through all these files if those things were like done one by one and change them. It's going to be one single place and it should reflect everywhere in the application. And another cool thing also, like I've been writing, there's not a lot, but I should do more of this. I only have this for UIKit, but I'm like testing, like if you're setting your window and everything is being set properly. Yeah, but that's something that I want to do more also, like write better tests that is going to avoid like regressions if big changes like that happen in the future.
Yeah, makes sense. Thank you.
Cool. We got 2 in the chat, so I'll read off the first one. Jenny asks, let's say I use SwiftUI. I have several views, one on top of another, and I need to go 2 views back. Close 2 views, like you're popping back 2. How would the routing handle that from the navigation stack perspective?
Yeah, so this would be handled through your, let's open here. Let's say, I think search is the good example. Where's the email view? Here, view controller builder. Yeah, we have the email, right? And we have the search view. So right now, I'm not, let's say that you go like down, like you open a lot of views in the stack. Right now, I'm not like passing this, this binding property down the stack. But let's say that you want to have control all over this stack that are going down. You just have to inject this binding through all your views. And whenever you want to dismiss stuff, you just like toggle this to false again, and you're going to go back to the view you want. Or if you don't want to go to the very first view, you would create your new like binding property in some point in between, and also like cancel when needed, if that makes sense.
Cool. And then last question from Paul. How do you handle data binding in SwiftUI when routing?
What do you mean about data binding?
I imagine if like you had a binding other than a Boolean and you needed to pass back data. Is there a way that if you come across anything like that?
You mean like communicating back and forth?
Yeah.
Yeah, but that's like, that shouldn't affect your routing. You could use like combine publishers if you want to. You could like as a dependency injection here, as I'm doing for, where is it? Go back there. Here I'm just injecting email, but let's say you want to communicate back and forth, you could use like a closure, you could use publishers with combine, you could use notification center, you could use delegation patterns. It's up to you. Yeah.
Perfect. Well, thank you. Thanks again. Let's everyone give Bruno another round of applause.
Oh, awesome. Hi, everyone. So welcome to this talk about Swift macros. I'm Stéphane Copin. I have been a developer, an iOS developer for about 11 years now. I currently work at Compass. So I wanted to do this talk about Swift macros because I feel like it's going to be a really powerful tool going forward. You might have seen that with if you've been using the new Xcode, like with the new predicate syntax or previews or the observable stuff. So I wanted to show you what they are and what you could potentially do with them, and show you all of that. So first, I'll start with what they allow you to do, just a quick overview. And then there are 2 kinds that exist. I'll go over a few examples and when they can be used. Then I'll go over some use cases that you could think of. I'll then demonstrate how you could write your own, and I'll do a quick demo about that. And let's get started. So what they allow you to do. So they allow you to generate and rewrite Swift code at compile time natively. So you have access to the source code that's associated with the macro, and you can either read that code or modify it. They can also generate diagnostic messages. So think warnings and errors based on the code that you read. And the code is read through what is called an abstract syntax tree, which I'll come back to. So there are two kinds of macros. One is freestanding. So freestanding is like error and warning or previews. They are basically substituted as anything that is an expression, and they can also trigger diagnostic messages. And macro can also be attached. So it can be attached to a piece of code then you have access to, and you can modify, add to, or anything you can think of in that case. Think of observable. So coming back on this, warning and error are now actually macros. They used to be just compiler directives. And you also have the preview and observable. And one that I wanted to explain a little bit more was a predicate. So you might have used the NS predicate in the past. If you use it, so you probably use core data or something similar, and you have basically this kind of syntax, and you try to run it. If you don't have it exactly, your app will just fail or crash, and then you'll try again until the app doesn't crash and it succeeds, and you have what you want. That's not ideal. So now you can do the equivalent thing using the predicate macro, which is used with Swift data, which kind of replaces core data for iOS 17. And the advantage of this is that you can use the SwiftSyntax to create your predicates. And that means that you can use the compiler to verify that the predicate is valid already, not at runtime. So that means that if your code compiles, you know that the predicate works compared to how it used to be. I'll admit that it can be tough to work with this macro, but I'm sure they will improve it in the future. And one feature that I wanted to show too is when you work with macro in Xcode, you can actually expand the macro and show what is being generated behind the scene or modified. So in the context of the predicate expression, you will see that it basically generates kind of a tree of expression. Like you will see that it's a conjunction that contains a key path and compare against a key path per day. But all this complexity is hidden from you just using the compiler. So Swift macros can be used in your current project if you target iOS or tvOS 13 or later. They can also be used for macOS 10.15 or watchOS 6. And you can use using existing macros in your project is pretty easy, as opposed to developing them, which can be a little trickier, especially if you go into the territory of modifying the code and adding code at compile time. So I wanted to go over a few use cases for macros. So for example, you could use them to create boilerplate code automatically. So this is like the case for predicate. Instead of using an S predicate, it basically generates something that something for you that is going to be compile time safe. But you could also think of, for example, a framework like TCA that could generate some boilerplate code on your behalf using macros. You could also add compile time safety to code that is not compile stuff otherwise. So you probably have had URLs in your code that you just hard-coded a string, and then you just force and wrap it. So there's not really another better solution here. But with macros, you can actually create a macro that will enforce that the URL is always valid at compile, and will just, instead of failing at runtime, if there's a typo in the space, for example, will just warn you at compile time or errors out. And furthermore, you can even go further and expand the compiler behavior. So playing with words here, you can't actually extend the compiler behavior, but you can replace it. So think of Codable. So when you use Codable and you don't want to do any customization, the compiler is going to do sensitization for you of the Codable protocol. But if you want to customize the keys, so you can just create your own coding keys enum, and then you can do that. But if you want to customize how the fields are parsed or decoded or encoded, then you end up having to actually do it yourself. And if you actually have an API that's special and you have to do this for every object, then you have to repeat this code for every object. So in this context, creating a macro that would automate this process for every object would probably save time in the long run. They are actually already open source projects for such use case. Like you have a macro codable, and then you can mark the fields that you want codable with a key, or that you don't want used, for example. So in terms of writing your own, so there has been a new set of libraries that have been made available by Apple in their GitHub org. So it's under a single repository called SwiftSyntax, and there are multiple modules available. I just listed a few here. So SwiftSyntax is the one that gives you a representation of the code as an abstract syntax tree. Come back to that right after. And you have SwiftSyntax macros, which gives you all the objects that you need to build your macro. And also you have SwiftSyntax Builder, which provides just a bunch of helpers to help you create pieces of SwiftSyntax, just to make it easier and more Swifty in a way, instead of interacting directly with the tree. So yeah, one caveat I did wanted to note is that it's only supported through Swift Package Manager. That means that currently, for example, if you use CocoaPods or Twist, so you have to add an additional step of adding this through Swift Package Manager. They are still working on some support because it's very recent. For the abstract syntax tree, so let's say you have this macro, which you can have in your code base. Pound error with parentheses, then you have string literal. This is what the AST is going to look like. So at the very top, you have the source file, which represents the whole thing. So this is just a subset of a source file. And you will have the macro expansion expression, which is basically this whole piece here. And then it's basically decomposed in the pound, the error, and you have the open and closing parentheses. In between, then you have the labeled expression list, which is a list of labeled expression. So here there's only one. In this case, labeled expression is a string literal expression that has a quote on both sides, and then just a list of segments. And here there's only one segment, which is this is an error. So this is how the code is represented in Swift overall. And you can see, so if you can have much more complex example of this. But overall, the goal is for it to be easy to read through when you write and when you read and write programmatically the syntax of a Swift file. So macro provides you with a node parameter, which is basically a representation of this. So now I'll go ahead and do a quick demo of how you can create a macro. So I'll be implementing the one I mentioned, which is creating a URL that is valid at compile time and throws an error otherwise. So if I go, I think yeah, I have to change screens. So okay. So I have Xcode here. So yeah, sorry. So I have an app. So this is just the basic app. I just called it iOSoho with a SwiftUI template. And let's say I want to add my own Swift macro. framework. So I just go here. So I add a file, a package, and I select the Swift macro, and I'm going to call it SwiftSoho macros because maybe there's going to be more than one. So I created within my iOSoho project. So it's going to be here. And you see there's going to be 3 files that have been created, 4 files, excuse me. And the first one is the definition of the macro as it can be accessed outside of your package. Then you have a file that is basically a sandbox for you using the your macros. You have the actual implementation of the macros here. And then you have a test. So you can make sure that your macro has the appropriate behavior. So by default, iOS creates this stringify, just as a small example of a macro. So in your case, well, let's call our macro URL. So our URL macro, we want it to take a static string because we want it to be a literal, nothing that can be computed at runtime. And we want it to return a URL. And we'll call it just URL macro. So we will modify it everywhere. We will reuse the stringify macro as the example from the example. And I'll come back to this. And no, actually. So here, this is the test macros that are going to be used by the test below. So here they're just passed, and then they're basically used if they're encountered in the test. So to develop this macro, I'm going to use some test-driven development, which is the easiest I found when developing with macros. So I'm going to write 2 tests. One test that generates a URL that is valid and no errors. So here I have a macro URL. So pound URL and then http://example.com, which is a valid URL. And so this generates a valid URL object. Now I have another test, which is not an invalid URL. In this case, I generate just an empty URL and a diagnostic that will say that the URL is invalid. So if I try those, they will fail, which is the expectation. And it might take, oh yes. So in order to use URL, you have to import foundation. And the tests are going to fail. So now we want to add an implementation. So we will add the valid implementation first, and then we'll add the error. So here, we want to first, so this is the node parameter that I was talking about earlier, where it gets you the macro expansion syntax. So it's pretty tough to explore the documentation if you look at it. And there is actually a very helpful website that has been created called Swift AST Explorer, which is basically what I showed before. And basically showed you the tree that we're looking to inspect. So in this context, we have the macro expansion expression, and we're looking for the labeled expression list. So we're looking for the argument variable. So once we are the expression list, we want the first one, because of how the macro is displayed, we only have one ever. So we want the first labeled expression. So we want the expression, which is going to be a Swift literal expression syntax. Once we have the string literal expression, we want to get a segment and just make that into a string, because that represents the string without the quotes. So if we come back here, the final expression looks like this. So we get the list of arguments. We get the first expression, cast it as a string literal, and then just get a description, a string representation of the segments. And then we can just return what we're looking for, which is this. and we want the row part. So now, if we run this test, we will see that our URL macro is generating the proper URL object, but we are not handling the case where the URL is invalid, which is not what we're looking for. So now let's add error handling to it. So what we want to do is verify. So we want to import foundation, and we want to just make sure that the string is a valid URL. So we just try and construct a URL from it and just make sure that it's not nil. And now, based on what we want just it to return an empty URL string. And the test is still going to fail, but we're closer because this time we're just not sending an error, which we're looking for. So to add an error, it's pretty simple. It's using the same mechanism that has been in Swift for a while, which is just using, you can define a error enumeration that conforms to error. And in this case, we'll just have one case, which is invalid URL. So we're just going to add one diagnostic when it's an error from the node, which is going to be error.invalid URL. And now we will have an error that has been outputted. However, just one more step we will need to do because the error is not really like programmer friendly. It's just an error code, and we want to say the URL is invalid. So in this case, we can just conform to a protocol called diagnostic message from the Swift diagnostics module. And it has three properties that needs to be implemented. Message, which we return the message we're looking for to return. Diagnostic ID, which is just a diagnostic for each possible errors. So in this case, we'll just use the raw value of the case for simplification. And the severity is just error, because we do want to return an error in this case. So, and now we have our test should pass, and we should have built the macro we're looking for. So now, if we are here and we want to try it, we will see that when we try it, this results in a valid URL, and the other will fail, which with an error that will prevent us from the code from compiling. So coming back to the presentation. Okay. Awesome. So we created a URL, a macro URL, and I hope that gave you a little idea on how macro can work. I didn't go too much into the details. There are more topics that could be explored. So each macro can have a role depending on what they generate and what they modify. And also I haven't really explored like the SwiftSyntax builder and how you can rewrite code that already exists, or even make like conformances to protocol, like which is all things you can do with Swift macros. So to end, Swift macros, I think, are going to be a great features that will be very helpful going forward. Swift data is one example with the predicate, but also the observable, the previews. They can be integrated in your project easily. There's already a lot of open source macros that you can use. And like I said, they can be integrated with iOS 13 or later, and then a bunch of other platforms for a few years ago. So developing macros can be more complex, especially if you're looking to do something that doesn't look trivial. But it can be a force multiplier and save a lot of time in the long run, especially if you work like in a team with multiple other people that might be doing the same thing over and over. It could be interesting to think about refactoring what you're writing. So I've included a bunch of links if you're interested. I think I don't know if the slides will be shared, but those links are there. And yeah, do you have any questions?
Any questions from the audience or from the chat? Right up front.
Hey, I'm just wondering why in the error case you returned the empty URL as opposed to something else.
This is a good question. So we just need to return a valid URL. I mean, a valid URL object for the compiler in this case. So I just chose to do the minimum possible object that could be returned because there's no like empty constructor for a URL.
I see. So even though we returned an error, it still has to be valid result.
Yeah. Otherwise, you could potentially get another compiler error that just could be confusing.
That makes sense.
Cool, very cool. Any other questions?
So did I understand it right that you need to use Swift Package Manager if you want to distribute the library that contains macros, or in general if you want to use them?
Unfortunately, for both cases, the infrastructure to use Swift macros and compile Swift macros is only available officially under Swift Package Manager. And that is the reason why it's only available there. Maybe they will improve it, but I've seen people trying to reverse engineer it and trying to make it like hack it into a Swift project. But we'll see. But officially, it's only supported through Swift Package Manager.
Okay, thank you.
Sure.
Cool. Any more questions? I have a question. Is there any talk around like the performance of these macros, like what it does to compile time or anything like that? I mean, I think simple checks like the URL or the codable are like great use cases, but is there any, like, is there like a buyer beware?
Yeah, that's a great question. Not that I'm aware of. In what I've seen, they haven't contributed to a higher compiler time. I'm not sure if it's because macros are very performant or if it's just very negligible compared to everything else that happens. But yeah, in any case, I mean, I would say that because the macro that you generate is either, so in this case, we generate a string that is then parsed into a syntax tree, right? But you can directly return a syntax tree. So that means that you don't, Xcode doesn't have to do the parsing already because it would already be done. So in that sense, once the macro is parsed, if you wanted to make it very performant, you just don't use string literals and you just create the pieces of the tree yourself directly. And I think in that case, you don't really, I don't think you will get performance that is too much.
Cool, makes sense. Thank you.